Page 2, Compound Probability. You randomly choose from a card from a standard 52 deck. Find the probability that you choose ace or queen. So or means addition. Or means addition. So there's 4 queens in a deck, 4 aces in a deck. So queen plus ace equals queen or ace. So probability of queen, probability of ace. So probability of pulling a queen is 4 out of 52. Probability of pulling an ace, 4 out of 52. Probability of pulling both, we're going to add, so 8 over 52, which reduces to Math Bracket. Math Bracket is your friends in this unit, guys. 2 out of 13. What is the probability you choose a king or means add, a club? There's 4 kings in a deck and 13 clubs, but wait, remember, 1 club is also a king. So that we've got an overlapping situation. So we're going probability of king or club. So we want the probability of a king plus the probability of a club, but we've got to subtract the guy who is king and club. I know, a little squirrely. So 4 out of 52 are kings, 13 out of 52 are clubs, minus that 1 king who is also a club. So 4 plus 13 minus 1 divided by 52. Math frac, so we got 16 out of 52, which turns into 4 out of 13. So remember, with overlapping, you've got a king who is also a club, so we've got to subtract it. Probability that you choose a card that has an even number or a heart. So this one's kind of annoying. So let's see all the possible numbers. So it starts at 2 because there is no 1, 3, 4, 5, 6, 7, 8, 9, and 10. So of those, 1, 2, 3, 4, 5 possible even cards. And then of those 5 possible even, there's 4 suits. So there's 20 even cards in our deck. So we got 20. Or means add. And then 13 hearts. Okay. So we want the probability. So remember, we're going probability it's even plus the probability it's a heart. But there are even hearts, so we got to subtract the cards that are both even and a heart. So we just said there's 20 out of 52 even cards, 13 out of 52 hearts. And then since we did all that counting on the right, we know that there's 5. So remember subtraction, dummy. 5 out of 52 are even. So 20 plus 13 minus 5 gives us 28 out of 52. We math frac that guy, and we get 7 out of 13. Find the probability that you choose a heart or a spade. Or means add. Great answer. Okay, we got 13 spades, 13 hearts. The question is, do we have any overlapping? If a card's a hard, combine them. If a heart is a card and a spade is a card, they are not going to be mutually, or they're going to be mutually exclusive, and they're not going to overlap. So, probability of heart plus the probability of a spade. So 13 out of 52 plus 13 out of 52 gives us 26 out of 52, which is, you can math bracket if you need to, but it is 1/2. Coin is tossed. 6-sided die is rolled. Probability that the coin is heads and the die is 5. Okay, there's our key word. And means multiply. So we're going probability of the coin. We want a probability of heads multiplied by the probability of a 5. So 1/2 times 1/6. Multiply straight across. I get 1/12. Probability that coin shows tails and the die is odd. And means multiply. Right? 50-50 for tails. 50-50 for odds. So we got 1/. So again, probability of tails and odd, T and O. Probability of tails multiplied by the probability of being odd. So 1/2 times 3/6. Multiply straight across. 3 out of 12, which reduces to 1/4. Always reduce, if you can help it. Always reduce. Our next one, an aquarium contains 6 male goldfish, 4 female goldfish. You're randomly selecting one fish without replacement. There's our guy. There's without replacement. You then select another fish. What is the probability that you select one that are both male? Okay, so probability of male given male. Okay, male and male without replacement. So we're going probability that the first one's a male multiplied by the probability that the second one's a male given the first one we pulled is a male. So for these ones, guys, we're going to assume that the thing we pulled is the thing we wanted. So if we said we pulled a male goldfish the first time, we're going to assume we pulled a male goldfish. So in our tank, there's 6 out of 10 that are male. We are going to assume when I pulled that goldfish out, I pulled a male. So now my top number reduces to 5, and my bottom number reduces to 9. If this first one said female, my top number still would have been 6 if it wanted to get a male the second time. But if it says we're doing it, so whatever it says we're doing, we're going to assume that is indeed what happened. So 6, so we're going to multiply straight across. 6 times 5 is 30. 10 times 9 is 90. So there is a 1 out of 3 shot that we pull 2 fish, and they are both male. So we're going to use the following information to determine whether or not our events are independent of one another, meaning the outcome of A does not affect the outcome of B. So to check this, we're just going to multiply A times B, and if our outcome is true, then they are independent. If not, there was some overlap. So the probability of A times the probability of B So A times B is 0.5 times 0.7, which gives us 0.35. Is that the same? It is. 0.35 is 0.35. So yes, they are independent of one another. There is no dependent. Nothing is affecting the outcome of the other. Looking at number 9, we're going to use the following information to determine whether or not the events are independent. We do probability of A times the probability of B. So 0.3 times 0.2, and we end up with 0.606. I'm sorry. So is that what they told me? And the answer is it's not. So these are not independent of one another. Something happened. The outcome of A affected the outcome of B. This concludes page